Hello again and welcome to the Snow Tornado lesson for RealFlow 10. This tutorial is our third and last part of the Dyverso Snow series, and I recommend watching the previous two videos before going ahead with this workshop. Otherwise, start with a D-spline daemon. Make it high enough and adjust its control points and handles. The spline shape has a strong influence on the final simulation, and therefore you should try to avoid very narrow curve segments. For this purpose here, a long spline with moderate curvature works best. The green circles indicate a control point's radius of influence. This means that only particles within this radius will be affected by the daemon. So it's very likely that you have to adjust the radius of some of the control points while testing. If you need visual control of the daemon's force field, make it visible and adjust its bounding box. It's also possible to transform and scale the box, and the arrows indicating the force's strength can be scaled as well. This way you will get a much better idea of how the particles will finally behave. For the snow, we also need a Dyverso circle emitter and a domain. Place the emitter at the first control point's position and scale it to, for example, 2.5 meters. Then we apply the standard settings from the snow parameters tutorial to the domain. This also includes substeps and iterations, as well as Dyverso's GPU mode. A more bluish color gradient creates the impression of snow or ice. You can find the colors under the Display tab. And the first simulation will give us an idea of what has to be changed. Yeah, and of course, the particles should be emitted along the spline. Well, the answer is pretty clear, because in fact everything's got to be changed. The material is very rigid and lacks turbulence, there is hardly any motion inside the particle cloud, and we also have these interruptions and escaping particles. And one reason for this rigid behavior can be found in RealFlow's simulation options next to the Simulate button. Iterations are set to 40 here, according to the settings we have been using in the previous snow tutorials. But now we go back to the standard value of 20. We also don't have any collisions or interacting objects, and therefore substeps can be set to 2. This will also speed up the simulation. I think the particles' behavior is much better now, but we're still far away from a tornado. So let's check if we can improve the material's characteristics. Friction is definitely too high, because we want the particles to move and flow freely. So decrease static friction to 0.3. Cohesion should be slightly decreased, and we need more roughness. Roughness creates a repulsion effect, and we need stray particles here. Stacking, on the other hand, is not necessary because our snow particles are not meant to create stacks or piles. So set stacking to 0. And in my opinion, damping is also too high at the moment, and a value of 0.5 should produce more turbulence. Then we simulate again. Okay, there's not too much difference right now, but the material has a less rigid appearance at least. For now we keep these values and work on the spline's forces, because the particles don't follow the given path. The active parameters in this section are global values, and they are multiplied with the individual values of the control points. Vortex creates a twist, but also lots of turbulence, and that's why we start with a moderate value of 2. Positive axial settings add an attraction force to the spline's axis, but for now we keep the default value. Radial defines the control point's force, and the circle indicates its scope. This way, the particles will be transported from point to point, therefore we need a rather high value. Something around 6 is good. Okay, let's do another simulation. And as you can see, the particles follow the path, but everything's still too viscous and too smooth. An easy way to add more turbulence is to increase the emitter's random values, but the particles are also too fast. A speed of 0.5 should give better results. What we have now is much better, but there's still not enough chaos. Cohesion should be decreased to get rid of this chopped look. Set it to 0.05. And we also need a strong noise field daemon with a strength of 3. Finally, we set resolution to 20 to get more particles. In this simulation, the look is much closer to what you have seen in the introduction, the rest is basically fine-tuning. Radial strength could be slightly higher, and I also want to decrease friction a little and change cohesion to 0.1. Some more roughness helps to get more stray particles and be ready for the next simulation. This preview is really good already, but I don't like the particles look in the spline's upper third. Of course, it's possible to adjust the affected control points individually, but here I want to dissolve the snow with a KH daemon. The quote-unquote bad behavior starts around frame 140. A variation of around 10 frames avoids an artificially looking sudden death of the particles. And what we have now is very close to the final look. Anyway, somewhat turbulence in the tornado's upper part is certainly a good idea. So we add another noise field daemon, but this time it will be bounded. Switch on the daemon's fall off and make it visible. Change the bounding type to sphere, and now it's possible to scale and reposition the noise field. Finally set strength to 6 and space scale will be 2. When ready, start a new simulation. The dissolving effect is much more natural now, and we're almost done. Just a few last modifications on the spline's forces. Here I'm going to apply a gradient from 2.5 to 1 to the control point's vortex values to get a more balanced look. And I also want to have a wider tube and set the first control point's remaining values to 0.5. And here is the final simulation with lots of snowflakes, a nice dissolving effect and strong turbulence. But despite these strong forces, the particles still have their snow-like appearance with differently scaled pieces and chunks. As always, thanks for your attention, and I want to wish you a great time with our Dyverso snow and grain solver. Goodbye!